In this video, we're going to take a look at problem 28-29. So in figure 28-29, we want to solve for the load current, I sub L, and the load voltage, V sub L, using A, the first diode approximation, B, the second diode approximation, and C, the third diode approximation. So if you recall from the reading or the lecture, the first approximation treats a forward biased diode like a closed switch with a voltage drop of 0 volts. So using the first approximation is pretty straightforward. You're just going to plug in the values from the drawing into Ohm's law. So let's write down what our values are. So first we have V sub L, and that is just going to be our input voltage, which is equal to 6 volts. Next we have R sub L, which is 30 ohms. Okay. And the formula is going to be V sub L is equal to I sub L times R sub L, which is essentially Ohm's law. So now the first part, we want to solve for I sub L. So we want to rearrange this. So I sub L is equal to V sub L divided by R sub L. And that's going to equal 6 volts divided by 30 ohms. And that equals 0.2 amps or 200 milliamps. Part B, we're going to use the second approximation, which treats a forward bias diode like an ideal diode in series with a battery. So the formula for that is going to be V sub L is equal to V sub N, or V sub IN, the voltage in minus the biasing voltage. Okay, so that's going to be 6 volts minus our biasing voltage. So if you look at the drawing, it tells us it's a silicon diode. So we're going to subtract 0.7 volts because it's silicon. And that's going to give us 5.3 volts. And that's our V sub L. So now, once again, we're going to use Ohm's law. And that gives us I sub L is equal to V sub L divided by R sub L. And that's going to be our 5.3 volts divided by our 30 ohms. And that's going to give us 0.1767 amps, or 176.7 milliamps. For part C, we're going to use a third approximation, and that includes the bulk resistance, or R sub B. So the formula for that is going to be I sub L is equal to the input voltage minus the biasing voltage divided by the resistance plus the bulk resistance. Okay. So that's going to equal 6 volts minus our 0.7 biasing volts here divided by 30 ohms plus our 2 ohms for bulk resistance, which gives us over here in the problem. So once again, we've got 5.3 volts divided by 32 ohms, and that's going to give us 0.1656 amps, or 165.6 milliamps.